So you've got the picture in your book. We're shooting this thing off a cliff, right? And this angle here is that 43 degrees? Right? Our launch velocity is 126 meters per second. So this might not be an air rocket, right? Okay, and then the cliff is 78.5 meters tall, so that's a tall, tall cliff. Right? And all we want to do is figure out, it's going to go and hit, and all we want to do is find out what this distance is here. And then it also says how much time is in the air, but we have to find the time to figure out the distance it goes, right? Okay. So the good news is we can just solve this with one of these guys. And the really good news is that we've solved a lot of arc problems so far. So what do we do? How do we get started? What's the first thing we got to do before we can even put numbers in that? What do we have to do? Yeah? You got to find the sine and cosine. This is very good. That's Max over there. Okay, we've got to do sine and cosine. Well, I think what he's saying here is we've got to figure out for this launch velocity, which I'll draw a little bigger here. Okay, for that launch velocity, it's got a horizontal component and a vertical component, doesn't it? Yeah. Okay, so find those horizontal and vertical components right now yourself with your own calculator. Okay, by touching your calculator and write them down in your own table. Do you want to show him how to find those components? Ryan's going to do this too. The recors are both going to do this. I see one recor that is calculatorless. Jen, get your calculator out. All right. How are we doing here so far? Amazing. If I walk around, am I going to see that on your calculators? Yeah. These things? Frida, do you want to help him how to do this?
Doesn't it have to be like its own form, like that?
Yeah, see, you're in your mode. All right, you want to be in degrees. There you go. Now try it again.
Another question.
Yeah. You can do that as soon as I see on your calculator that you've got these. Figuring it out. You got it. That's good. This is marvelous. Could you get a calculator out and do this, please? Here we go. Look at this. We are cooking with gas.
Hey, we should fix his calculator. His calculator just tells him what he put in. Look at this. Look at this. Type in 126 sine 43.
Yeah, I have no idea how these work. Try this. Yeah, you got it. Now you can go. Just tuck it into your arm like a football. Are we good so far? So we've got that. Now we have everything. Now we have everything we need. Now we have everything we need. Somebody won like an iPod with those things. I gotta start giving those out. Why can't my students win iPods, you know? Like Aya Rosalind got called down to Gomez, right? He got called down to Gomez and weren't you helping him? You were helping him, weren't you? Yeah. Yeah. Right. Anyway, she got an iPod Shuffle, which I don't know. I mean, anyway, for like they have a drawing. You turn those in. You turn that into somewhere the SAO, don't you? Yeah. I don't know. Okay, so let's go with this. We've got these numbers. Now we're ready to put stuff. So any problem that gives you an angle magnitude vector, break it into components, and then say, I don't know what to do. But then you probably still know what to do, right? So raise your hand if you know where something goes. Max has got something.
I know that the horizontal acceleration is 0.
Yeah, there we go. That's a safe bet, right? Who else has got some? Kelly's got something.
Vertical x is
But it goes down, right? So it's
negative.
down 78.5. There you go. That's a crazy thing. There we go. Braden's got something. Indeed it is. Man, we are going to solve this thing together. How bold. Frida's got something.
85.32 goes in the initial velocity.
Yeah, initial velocity vertically, right?
And then it goes negative.
Okay, so then she wants to make it negative 85.932. That was a trick we did when it was a level field, like it lands at the same elevation, right? But I bet we can't do that here because it's not level, right? So this is the one trick. This is the one thing, right? It's like, yeah, that is the one thing that's not going to be just like any other arc problem, okay, when we're filling this thing in. And who else has got something? Somebody else has got something. Somebody else. Actually, Ryan's got something. Could you guys just pay attention and not chat? Okay, I think sometimes when we're sitting next to our friends so close, we're tempted to chat. But I want to be the center of attention. Okay, so now I think we've got a quorum. We've got 3 on this side. This side's solvable now, isn't it? It's not easy to solve. It's a little harder than the other one, right? And then one of the things we'll solve for is time, and then we ought to be able to figure this out, right? So now we're looking for equations that we can use. What do we want to solve for? This guy first or this guy first? Solve for time. Okay, so do we have a formula that's no VF? That's the trick, right? Does one of those formulas have no VF? The bottom one does, right? So let's just set that guy up. X is VI, t plus 1/2 AT squared. Let's plug in our numbers. So negative 78.5 equals 85.932 times the time that we don't know plus 1/2 negative 9.8 times the time that we don't know squared. Yeah? And then we look at that. And we look at it. And is that going to be easy to solve for time? No, why not? Unless we use Wolfram alpha, we're going to have to use the quadratic equation to solve it. We're going to get 2 roots, one negative, one positive. The negative root, by the way, would be the time before now that you could launch it from someplace here, so that when it reached here, it would have an angle of 43 and be going 126 meters per second. And the positive root would be the one where it strikes the ground. Do we want to do that? No, so let's just sort of go, I don't know, right? Like, okay. So we could, if you remember the quadratic equation, go for it. It's not the negative root, it's the positive one. Okay. Now, what else could we solve for? Well, if we can't solve for t, what could we solve for? The final velocity. Which one's going to find us the final velocity?